down. There we go. This and this. All right, finally, last problem here. I believe it's the last problem. Find the 85th derivative of cosine of 2x. First of all, notice that we have an outer function cosine of something. The thing inside of it is 2x. So this is not just a simple derivative. You actually have to apply the chain rule. What we know is that y is equal to cosine of something we'll call u. The u is what's inside is 2x. If we make our table, take the derivative of y with respect to u will be negative sine u. Now the derivative of u with respect to x will be 2. So multiplying those two together, you get negative 2 sine u. But what's u? U is 2x, so negative 2 sine 2x. So that's what our first derivative is. Okay, that's our first derivative. We want the 85th derivative, but that's ridiculous because if we do this again, we're going to, we're going to have to do it another 84 times. So what we want to do is try and see that there's a pattern. Okay, so if I take the derivative of this again, what will happen is we'll have the derivative of, the constants here, so that's negative 2. Don't worry about that. And then when I take the derivative of sine 2x, I have to come over here again and say y is equal to sine of something. The something is 2x. And then I set up my table, and I do my chain rule again. What you get is 2 cosine 2x. So that would be my second derivative. Then the negative 4 is a constant out front. And now you'd have to set up your little box, do chain rule on that again. But we already know what the derivative of cosine 2x is. That was the first thing we found. So we already know that that would turn into negative 2. This was our derivative right there of cosine 2x. Negative 2 sine 2x. So now I have 8 sine 2x. So this is my first derivative, f prime. This is my second derivative, f double prime. This is my third derivative. So there's a pattern here. Notice that whenever, hold on a second, maybe I should go one more so we'll be convinced of this. Let's go. Hold on a second. I'm getting a text here. Let me pause this. I got to answer this. Okay, back to this. Yeah, I think what I'll do is I'll get rid of this, and what I'm going to do is I'm going to list out what the derivatives are, so you can kind of see the pattern that's being created here. All right, you see how to do each derivative. So we know y. We know that y was equal to cosine of 2x. When we took the first derivative of y, we got negative 2 sine 2x. When we took the second derivative, we got negative 2 times 2 cosine 2x. Now, I'm not going to put the negative 2 and 2 together for a reason here. When I take the third derivative, I get negative 2 times 2 times negative 2 sine 2x. And then when I take the fourth derivative, which I'll have to write like this, I get negative 2 times 2 times negative 2 times 2 times cosine 2x. And I keep doing this. Well, notice what's happening here. Let's see, if I were to put this together, I've got 4 2's being multiplied. 2 of them are negative, 2 of them are positive, so this should be a positive number. That should be 16 cosine 2x. Over here, put these together, I get, again, a positive, right? Positive 8 sine 2x. And then these two, let's see, when I put those two together, I get -4 cosine 2x. And then when I put, there's nothing put together there, I get -2 sine 2x. So it looks like the first two derivatives are both negative, and then the second two are both positive. Let's see, what would happen if we do the fifth derivative? Of course, I'm not going to go all the way to 85, but I would get -2 times 2 times -2 times 2 times, now when I take derivative of this, that would pop a -2 out, and then I'd have sine 2x. So now I have 3 negatives in there, so I'm going to get -32 sine 2x. And when I take the derivative again, sixth one, what happens is, because all of these numbers out here are just numbers, I have 3 negatives. All I'm going to do is pop a 2 out. It's going to stay negative. So I'm going to have a -64, and then the sine turns to cosine. So again, these two were negative. If I go one more, I promise this last one. I'm just really trying to get you to see the pattern. I'm just going to have another 2 pop out. Sorry, a -2 is going to pop out because I'm going to be taking derivative of cosine. And that negative is going to join the other 2's that are out there. And it'll change it to a positive now, 128, and the cosine turns to sine. So the next two should be both positive. So we got positives, negatives, positives. These were negatives. So the question would be, you know, where would 85 lie in this? You know, would 85 give us a positive or negative? And then also, you know, what's the pattern with the 2's? Let's look at the 2's first. If you look at this first one, just the number out front, that's 2 to the first power. Forget the sign. The 4 here is 2 squared, and notice that the first derivative first is 2 to the first. Second derivative, we get 2 squared. Third derivative, that 8 is 2 cubed, so that's going to be third. So it looks like the derivative tells us how many 2's we have. So if we're looking at over here y to the 85th, we know that we should have 2 to the 85th power. And then we need to determine if we're going to have a sine or a cosine. So let's see. First derivative, we have a sine. Third derivative, we have a sine. Fifth derivative, we have a sine. Seventh derivative, we have a sine. So it looks like all the odds we get sines. So we should get a sine 2x here. And the question now is it positive or is it negative? Well, again, which ones were positive? The ones that were positive were 2 and 3. Wait, hold on. No. 3 and 4. The third and fourth derivatives were positive. 6 and 7. No, I'm messing this up. Hold on. Okay, it was like this. Okay, so which ones were positive? We had derivatives 3 and 4, derivatives 7 and 8. We didn't put 8. So what would the next ones be? Well, these are just going up by 4, right? So you add 4 here, you get 11. You add 4 there, you get 12. And the question is, where is 87? Is 87 in this list of numbers? Well, we could look at this first list as being 3 plus multiples of 4. And we ask ourselves, is 85 there? So let's try and solve this. If we subtract 3 from both sides, we get 82. Does 4 go into 82 evenly? So will I be able to find an integer that will make that happen? And then, no, it doesn't. So let me try this. Let me try the other list, which is this one. 4 plus multiples of 4. Does that ever equal 85? So does 4n ever equal, subtract 4, 81? No, that's not going to happen. That's not an integer. So I know it doesn't happen in either one of those lists, which means it has to happen in the other list. We're pretty much done. Okay, we can say that this is negative, but let me show you, why it's in that list. The list where we got negatives was when we had derivatives 1 and 2, 5 and 6, and again, we could see we're just adding 4 to these each time. 9, and 10. So this first list is basically 1 plus multiples of 4. Can that be equal to 85? We'll subtract 1 from both sides, you get 84, and then divide through, and you get 21 for n. So it looks like, yes, there is some integer where we will get 21, so it will appear in that list. Therefore, it had to be in the negative list. Therefore, that's our answer. A little bit involved. Now let's see. I had brought up where their answer. I think it's this one. They really just kind of jump over everything, but here it is right here, same result. Okay, let's see where my video time is here, 43 minutes. Yeah, I'd like to try and redo this. Let me erase everything and come back. Okay, I'm going to work through this homework again, but I'm going to do it the way that eventually you would like to be able to do this without all that table stuff. So here's my first one. I want to find the derivative. Okay, so the way I do this is I say, okay, the last thing happening is cube root, so I'm going to act like I'm just covering that up. And I'm saying that that's something to the 1/3. Well, what is the derivative of something to the 1/3? It's 1/3 times that something, and then subtract 1 from the power, you get this. Now, what was it that was raised to the 1/3? It was 1 plus 5x. Okay, now that I've done the 1/3, I look inside and I say times, what's the derivative of what's inside there? Well, the derivative of what's inside there is just 5. If you check it, that's exactly what we got earlier. Okay, this one, again, I have something raised to the 4th power. So if I want to know what the derivative is, I know the derivative of something to the 4th power is 4 times that something to the 3rd power. Now, what was the something? The something in here was exactly x to the 4th plus 5x squared minus 5. Now, I've done the 4 on the outside, and now I need to look inside and say what's the derivative of that, and just attach it here with multiplication. Derivative of that is 4x cubed plus 10x. And if you check again, that was the answer we got earlier. Now, for this one, I can't avoid the fact that I still have to use quotient rule, okay? But I can still do this without writing a whole bunch of stuff down. The derivative of this will be the derivative of the top, which is 1, times the bottom, minus the derivative of the bottom. So let me just write that down right here real quick. There's the bottom. The bottom is the square root of something, right? Here's the something, and then I have a square root on the outside. Oh, getting a phone call, sorry. Okay, so the thing on the outside here is the square root. So I'm trying to figure out what is the derivative of the square root of something. Well, it's 1 over 2 times the square root of that something. But what was the something? The something was the r squared plus 3. Now, because this is a chain rule, I now need to attach to that the derivative of what was inside. Now, the derivative of what's inside was 2r. And then, because of the quotient rule, I need to attach to that, next to it, the r, which was, let me get back up here, f prime g minus g prime, and then here's f. And then all of this is over g squared when I square the bottom, and you just get that. And again, if you look back, we should have had that result earlier. The 2's canceled. I had r squared up here. You know what? I don't remember having r squared up there. But I think we did. Yeah, because it canceled with that r squared. Yes. Okay, so that is correct. All right. Next one. This one's going to be a little bit cool because you'll see how this works out so much easier if you can do it the way I'm doing it, right? Instead of what we did with this one earlier. So I'm going to start with the outside. Okay. What's the outside function? Well, it's the square root of something, right? What's the derivative of the square root of something? It's 1 over 2 times the square root of that something. Now, what's the something that I'm talking about? Well, I'm talking about everything under here. So I'm just going to tack that on inside here. 5x plus square root 5x plus square root 5x. So what I've done is I've taken care of the blue part. So I no longer need to consider that outer square root right there. Okay, I'm done. So chain rule says now multiply that times the derivative of what's left. So here's the stuff that's left without the square root. Well, what's the derivative of that? Well, the derivative of 5x, which is its own term, is just 5, plus, now again, notice I have a square root again, and underneath it I got a bunch of junk, so I'm going to have to do chain rule. So what's the derivative of the square root of something? Well, it's 1 over 2 times the square root of the something. Now here the something is just the 5x plus the root 5x, so that's what goes in there. It's the something that I was taking, that was raised to the, or that the something is the part that looks green there, right? Okay, now chain rule says continue times the derivative of that green part. Well, the derivative of the green part is just 5 plus, and then we did this earlier. What's derivative of this? It came out to be root 5 over 2 root x. And that, close that parentheses, that is exactly what we would have had earlier, or that is exactly what we had earlier without all those steps. This technique requires a little bit of, work, I guess. You have to get real comfortable with it, but so much quicker once you get it down. Okay, look at this one, f prime x. Okay, remember we had 2 terms, so I can just do these individually, 2 cosine x plus, now here I have something being squared. The derivative of something being squared is 2 times that something to the first power. Now what was the something that was being squared? It was the sine x, so that's what goes in here. Then times, now that I've done the squared, I take derivative of sine x, which is cosine x. And of course, sine x to the first power here is just sine x. So we get 2 cosine x plus 2 sine x cosine x. And that's the same exact thing that we had earlier. All right, now this one, there's no easy way to do it other than the way I showed you. So there's not going to be a shortcut there. You still have to, find the pattern and get your derivative. All right, see you.